E-learning with NUT Endomodel Science School, Mina.
Hello, you welcome to today's physics class by teacher Muhammad Aliu. In physics today we are going to learn about heat transfer. Heat is a form of energy, like you have known in your previous classes, that is derived from rise in temperature of a body. So due to rise in temperature of the body, there is usually a transfer of heat. Heat can be transferred in three major methods. These are conduction, convection, and radiation. Today we are going to talk about conduction, effect, and application. Before we go, let's look at conduction. Conduction is the method of heat transfer through a body or from one particle of a body to another particle without the actual movement of the particles. Now, what does this mean? When we say actual movements, we are talking about particles. When we say the movement of particles, recall some of those laws you have studied in chemistry. Law of constant composition, which states that matter is made up of tiny particles called ions, molecules, or atoms. So these particles can be found in any form of matter. Now, any form of matter, being it solid, liquid, or gas, are made up of these tiny particles. These tiny particles come together to give you the real matter itself. Now, whenever heat is transferred or whenever that body is heated, there is usually a transfer of heat from one particle to another. Now, in solids, these particles are held together by strong intermolecular forces of attraction. Now, these forces of attraction do not allow the particles to be able to move freely, just the way you have it in liquid and gases. The particles of solid are fixed and are not allowed to move about. So because they are not allowed to move about, they transfer this energy from one particle to the next until the heat reaches the last point. That is the reason why if you hold a metallic spoon, an iron spoon in one of your hand, and then put it into a hot boiling water, continue to stir, the whole spoon feels hot later to the point that you won't be able to hold the spoon again. What happens? This is because the particles that make up this spoon are conducting this heat, transferring it to themselves without them moving. Such type of heat is called conduction. Such type of heat transfer is called conduction. So conduction is a heat transfer in solids mainly. However, we can have conduction in liquids and gases. Thermal conductivity. The word thermal conductivity, thermal, is gotten from the word heat. Thermal and heat are synonymous. So when we say thermal conductivity, we are talking about the ability of a solid material to be able, ability of or measure of the material to conduct heat. Different types of material have the ability of conducting heat. For example, if you put wood on fire, or if you put wood in a burning fire, the whole body feels warm. However, but wood does not conduct the heat readily. and then it is rarely or even impossible for you to feel the heat at the under part of the wood. If you put plastic in fire, you will notice that the plastic will just melt without even transferring the heat. But once you put iron inside fire, before you know it, one end of the iron will be hot, and then the whole body of the iron will be very hot, to the point that you cannot even hold the iron again. So we have a chart of materials that we have a chart of material and their thermal conductivities. Silver is having a thermal conductivity of 418 watts per meter per coulomb. Copper 385, brass 109, mercury 8.0, ice 2.1, glass 1.0, water 0.6, air 0.024, and cotton wool 0.02. Now it means that silver has highest thermal conductivity, followed by copper, followed by brass. Now if you have silver at home, or you use silver to wire all your houses, then this silver may not likely burn because it has high thermal capacity. You may not experience any form of electrical fault due to heat or due to any fire incident. This is because the silver can bear as much heat as 418. Are we clear? Now, what we are trying to say here is that silver retains and conducts heat faster than copper, and copper conducts it faster than brass. Copper is the best material for electricity because it has high thermal conductivity and electrical conductivity. Likewise, silver. The only problem with silver is that silver is very expensive. If you use silver to wire your houses, armed robbers will just come to your house. They will not steal anything. They will just steal the wires and carry it. This is because silver is very expensive. Okay. The next is conduction in liquids. Liquids also conduct heat, but conduction in liquid is usually very poor. Sometimes when you are heating water in a bucket and then you put the heater on by the side of the bucket, you will notice that only the part of where the heater is, that is where that region is the only region that will be very hot, and the other surrounding will be cold, and then the heat will be slowly transferred to other parts of the body. Now in these experiments that you are going to see in this video, we will have ice, and that ice will be submerged in water, and you will notice that the top of the water level at the top will be boiling, whereas the ice has not even molten. So let's watch and see. Okay, look at it. This is our ice. So this is our ice. So like you can see, this ice is pushed under the water by a wire gauge, and then the top level of the water is heated. After a while, the water at the top will keep boiling. Can you see it boiling? Yeah, but the ice has not molten. Can you see it here? The ice has not molten. The ice is at 0 degrees Celsius, whereas the water at the top is at 100 degrees Celsius. Now this point one fact that water is a poor conductor of electricity. Now since water is a poor conductor of electricity, we can conclude that liquids are poor conductor of electricity. Not only water, with the exception of mercury, which is a metal in liquid form at room temperature. All liquids are poor conductors of heat. Water, groundnut oil, diesel, and any other liquid you will think, except mercury, are poor conductors of heat and electricity. Now, conduction in gases. Gases are also poor conductors of heat. They are even poorer than liquids. However, we cannot demonstrate this using simple experiments, but an illustration can help you. Now, when you put your hand around the boiling pot of water, you see that the water doesn't boil your hand. Instead, your hand feels warm while the water boils. This points to one fact that gases are poor conductors of heat. Okay? Application of conduction. Conduction can be applied in the use of blanket and clothes to keep warm. Our body traps in a lot of heat, and blankets are very poor conductors of heat. Since we know about that, we can use blanket to cover our body to retain the heat that is lost to the surrounding. Now, this is an application of conduction in our everyday life. The next one is the application of conduction in cooking utensils and their handles. If you look at it closely, cooking utensils like pots, knives, tablespoon, some spoons, and even our cookers at home, you will notice that they are made up of handles. These handles are insulated handles. Now, the handles may be made up of wood, plastic, rubber, and this is to prevent the heat from reaching your hand. That is one application of conduction. Since these materials are insulators, they will not allow the heat to reach your hand. Poor conductors of heat, remember? Now, application of conduction in refrigerator. Now, a refrigerator, the inside environment of a refrigerator is very cold, to about temperature that is less than 0 degrees Celsius in the refrigerator. But our environment outside the refrigerator is usually very warm. So to prevent heat from reaching the inside environment of a refrigerator, the refrigerator is usually lagged with an insulated material to prevent the warmer air from coming into the fridge. This is another application of conduction. The use of thatch roofs. Can you see this thatch roof? Thatch roofs are made up of grasses. Like you can see, grasses are poor conductors of heat too. So because they are poor conductors of heat, they do not conduct heat that will make the rooms or the house generally to be very hot. Instead, they will make it to be cool and habitable for the body to live in. So thatch roofs are application of conduction to our everyday life. The use of rocks also is one application of conduction. When you step your sole or your leg on a tile, a floor that is tiled, you will notice that the floor is very cold, but putting a carpet makes it feel warm even if the tile is cold. This is to prevent the cold from reaching your leg or reducing it to the barest minimum. This material is a very poor conductor of heat, and the application of this material helps to reduce cold from reaching your leg. So I hope you enjoyed this class. This is a take-home assignment for you. Name 5 other materials that are good conductors of heat. Arrange these materials based on their thermal capacities. Thank you very much. Enjoy the rest part of your day. Don't forget to stay safe, stay at home. Bye.